And that's why we, first of all, that's why we need red teaming, and secondly, why this red teaming is different. We currently have like different, so different people think about the red teaming, AI red teaming as kind of a different subjects. So if you talk with the AI related people, usually they think of AI red teaming as a testing for all types of unusual behavior. It can be safety, it can be bias testing, it can be compliance testing, and so on. So it's a whole broad range of things. It's like a quality assurance, but specific for AI. If you speak with the security people, they think about the AI red teaming in terms of like specifically security focused testing. But no matter if it's a security guy or safety guy, red teaming means basically the structured testing using to find some unusual behavior that in AI application that it should not be here. And the need for AI red teaming was, it's not something new. It was mentioned like for almost more than 10 years. First, it's usually started in academia in 2014. Some of the ideas about like, actually there were the first examples of adversarial attacks on computer vision mentioned by Ian Goodfellow. Later, I think it was probably the first presentation where I mentioned the AI red teaming specifically. Then we conducted multiple red teaming publications specific for computer vision because there were no language model and at that point of time. Well, they were, but not in such a case like we have right now. And then the red teaming for language models became like more common. And now, yes, there's a mistake here. In 2025, we have a red teaming approaches for agentic AI, which is, I would say, not completely, but really also very different from red teaming of language models. But that's the whole new topic for discussion. And a lot of enterprises are implementing AI red teaming and building their own internal teams, like Microsoft. They just recently released some report on red teaming GPT-5, and I think they mentioned like the team was 70 people focused on AI red teaming in Microsoft. It's probably not the whole team, so it's around like 100 or more people working on AI red teaming specifically at Microsoft. So and even
Alex, sorry, just a quick clarifying question for the non-technical people listening. If there's a lot of people in policy that don't understand the technical terminology, can you summarize in one sentence why this risk is so important for getting it right? What could go wrong? Just give one example.
Sure. So I mean, for a language model is unpredicted, and it's basically constructing the output like you want. So if you ask the model how to, it's a typical example. If you ask the model how to create a bomb or how to perform the cyber attack, so AI model can help you to perform the cyber attack. It actually can do this cyber attack. So if you to put this model in some autonomous agent and do some things, this model theoretically can perform a cyber attack. Not only if we ask this model to do that, but probably just because the way how to perform the goal that we ask this model to do can include the option to perform a cyber attack. Like you can say, hey, develop some new system. And the model will think and understand that developing new system is harder than going to the GitHub and hacking someone's account and downloading the system. And that's probably one of the examples that what can go wrong.
Yeah, and just to highlight this, right, there are examples of cyber attacks, for example, in a water treatment plant in Florida. So you can imagine if bad actors are leveraging LLMs to hack critical infrastructure systems, food, water, etc., you see as a policymaker how dangerous this can be. It's also on the financial system, people's individual banking accounts. So there's a very severe threat of cyber attacks.
Yes, absolutely. And there's another angle when we have these agents that perform different actions for the enterprises, because enterprises are creating agents for sales, for customer support, etc. And those agents can be hacked if you don't do the red teaming, because it's basically the structured testing, like what the agents and the model can do. And you can hack the system, and you can take the personal data to if the system have access to the personal data. So that's probably will be some more detailed examples later in the presentation. But yeah, thanks. That's the great question. And even the companies like Gartner, who usually predict what will happen next, they mentioned the new emerging role, which is called AI model validator, which is the intersection of the data science knowledge, the quality assurance, and like the penetration testing. I'll probably add some more knowledge types for AI red teamer. For example, you need to know like linguistics to perform different types of jailbreaks. You need to know social behavior, mathematics, and etc. And you will see later that different types of attacks on AI applications may require different, like absolutely different skills. And yes, like the applications, the way how we develop applications are changing, and we previously used to have some, user interact with the application, like a website or app. This application have some database, and this database and the information, like the whole information, can be stored on files and documents. So now we have a new approach for building solutions. We have some data set, then we train a model based on this data set, and then we have an agent which call this model with specific prompts. And this system is now a new type of application. So sooner or later, we will not have traditional applications and websites and so on. Everything will be like more or less agentic. So what are the threats? What are the attacks? What's happening? I'll start with the AI in general. And like probably 4 years ago, we released the first paper called The Road to Secure and Trusted AI. And we mentioned what are the top categories of attacks specific for AI. Not for language models, but AI in general. And there were like manipulation attacks when you demonstrate some input to the model and the output is different. There were examples like adversarial examples. You can create essentially a sunglasses with some pattern, and if you wear these sunglasses, the face recognition system will not recognize you. So that was an example of manipulation for AI in computer vision. And there were like extraction attacks. If you have a model, you can perform different methods to extract data, and infection attacks, like you can backdoor the model. Now we have language models, and the number of AI-specific attacks or on language models has increased. We have things like jailbreaks and prompt injections that you probably heard of, but we also have some new, less known attacks like RAG poisoning or RAG backdoors, supply chain attacks, and so on. So, and if we look at the agentic AI, there are even more specific examples of AI agents, because agents have memory, agents can call tools, and agents can interact with other agents.
And Alex, just to clarify for non-technical people as well listening, could you just give one example or a quick overview or sentence about each type of attack and what that means?
Sure. So for manipulation, as I mentioned before, you create an input for AI application, like you wear glasses for computer for face recognition system, and those glasses like manipulate the decision of a computer vision system, the decision of this computer vision system now to allow you or not to allow you to enter some building. The extraction is when you have a model, and using some techniques, you can understand it's actually relevant for policymakers. So using those techniques, you can understand if a particular example of the data set was used to train the model. So sometimes it can be important to understand if this data set was stolen from somewhere or was used without proper rights for this content. An infection, it's like let's say it's a backdoor. So let's say you have some company can develop a model, like a open source language model, and upload it to the internet. and you can download this model because you want to use open source, but you don't know that the guy who uploaded this model, they inserted some malicious behavior in this model, and you cannot really understand if this model have a backdoor because it's very complex to know it. So once you implement this model in I don't know, in your chatbot, this model can provide root answers to particular questions, let's say to the questions related to some company name. So those can be some examples for
So just to illustrate with some examples related to the top 10 existential AI threats, you can imagine, first of all, there were some examples of some Chinese robotics companies that had a backdoor in the code for some of their robots. And so if you purchased a Spot type dog robot copy, there was actually instances where those robots were monitoring through their cameras, recordings, microphones, etc., and sending that data back to this Chinese company. And so effectively, the robots were spies on whoever purchased them. As for the manipulation, you can imagine if one of these attacks was used on a critical infrastructure system, and that was used to then cause harm, suffering on different users, that would be extremely bad. And then for extraction for sensitive data like healthcare at a hospital, people's private information for finance, anything like that, right? So there's real world impact that clearly breaks the law in many different ways. And for policymakers, it's really important to understand the laws that would need to be put in place to avoid these kinds of things happening in the future, and for the public to understand the risks when using different AI companies that don't have a trustworthy background.
Yes, thanks for translating my technical examples to more broader ones.